Farhad, and today we're going to be talking about the impact of structural design patterns on software evolution. So, some crucial design patterns. Structural design patterns play a crucial role in software evolution because they provide a framework for organizing code in a flexible and scalable manner. And so, some examples we're going to look at today include the proxy pattern, MVC pattern, and also the decorator pattern. So, to begin, let's start by looking at the proxy pattern. So what is proxy pattern? Proxies serve as placeholders for objects to control and access them, and they can be used for various purposes like implementing lazy initialization, access control, logging, and monitoring. And proxies can be easily swapped out or extended, facilitating software evolution without altering any of the underlying components of the system. So for example here, if clients want to access the database rather than going straight to it, they can work through a proxy, if that makes more sense. Let's look at how this impacts software evolution and how it hinders it and how it also facilitates it. So in terms of facilitating software evolution, proxy pattern, it promotes transparent access control, which allows developers to implement access control mechanisms very transparently, where they can see the features and functions. And it also allows for better control over how clients interact with objects, and it also facilitates changes in access policies without modifying the component itself. Additionally, as I said earlier, it also promotes lazy initialization. So proxies can be used to defer to the creation of initialization of expensive resources until they're actually needed. And so this supports efficient resource management, and it can also improve performance, especially if your system has large or complex object graphs. And finally, another way to facilitate software evolution is through the use of remote proxies, which proxies can represent objects located in remote systems. And we can abstract the details of communication protocols and network interactions using these proxies. And this promotes loose coupling, which means your code is more scalable. And additionally, the evolution of distributed systems, it helps it by hiding complexities of remote communication. And then on the other hand, how does proxy pattern hinder software evolution? It increases complexity. So introducing proxies, it can add an additional layer of complexity to your system, especially if you use multiple different types of proxies or if they're chained together. Additionally, proxies can introduce performance overhead, especially if they involve additional processing, or responsiveness and scalability can be impacted if they involve network communication. And especially performance critical applications or systems with high concurrency, this could be an issue there. And finally, it does also kind of promote tight coupling. So if you poorly design your proxies, it can result in a very tightly coupled system, which of course makes it less scalable, less flexible, and overall worse for your software system as a whole. Now next, let's take a look at MVC pattern. This one's quite popular. So what is it? MVC stands for Model View Controller. And Model View Controller pattern separates an application into 3 interconnected components. You have your model, which is the data and the business logic. You have your view, which is the presentation layer. And you have the controller, which handles user inputs. And by separating these two, it facilitates the evolution of each component independently without having to worry about the others. And it enables changes to the user interface, business logic, or data model without affecting the other parts of the system. So how does this hinder and facilitate software evolution? In terms of facilitating software evolution, it separates concerns. So by separating the application into 3 interconnected components, the model, the view, and the controller, it facilitates software evolution by allowing changes to one component without affecting the others. So for example, you can update your view without updating your models or your controllers. And this just makes your project overall more scalable, more modifiable. Speaking of modifiability, MVC also promotes modifiability by organizing your code into distinct layers based on what responsibilities they have. And it makes it easier to understand and maintain and evolve each component separately and it also reduces the risk of unintended side effects when making changes. And finally, MVC also encourages the reuse of components across different parts of your application or project. So like a well-defined data model can be used as controller logic in multiple views or interfaces, and in this way it facilitates software evolution. On the other hand, it hinders software evolution by introducing another layer of complexity compared to simpler architectures, especially if you have a very simple and straightforward application. To understand the connections between your model, your view, and controller, this can obviously add more complexity to the project. Furthermore, MVC also encourages tight coupling, especially if you design it poorly, and the poor implementations of it can lead to your components being very intertwined, which makes it difficult to modify or replace one component without affecting the other ones. And additionally, MVC introduces a lot of overhead in terms of communication between your components, because you have to create communication between your model, your view, and controller, especially in scenarios where you're frequently updating or synchronizing between the model and view. In this case, there's a lot more overhead. And now let's take a look at our final pattern, which is the decorator pattern. So again, we ask, what is a decorator pattern? So this pattern allows behavior to be added to individual objects dynamically. So it makes it flexible and easy to evolve, and you can add new decorators without modifying existing code. So for example, it's like putting on a sweater or putting on a coat. You don't change the existing thing, but you just put something over it. And how does this hinder, and how does it facilitate software evolution? In terms of facilitating software evolution, it provides us with dynamic functionality, which allows different behaviors to be added to individual objects and without having to modify their structure, and it promotes flexibility, extensibility. It allows developers to evolve the system by adding new features or modifying existing ones. Additionally, it promotes code reusability because you can encapsulate additional functionality in separate classes, and you can apply these decorators to multiple objects or have them be reused in different parts of the system. Thus, you reduce duplication and you simplify your maintenance and evolution efforts. And finally, decorators adhere to the open-closed principle, which states that your software entities should be open for extension but closed for modification. And this is very good for software evolution because by allowing behavior to be added rather than inherited, decorators support evolutionary changes without modifying existing code. On the other hand, how does this pattern hinder software evolution? Well, it increases complexity because introducing decorators adds an additional layer of complexity to your system, especially if you have a large number of decorators or if you have complex interactions between them. And this can make your code more difficult to understand, more difficult to maintain and evolve, especially if you're a new developer who's unfamiliar with a pattern. Furthermore, applying multiple decorators to your objects, you can introduce a lot of performance overhead, especially if each one of your decorators is complex and if it involves some type of processing or introduces inefficiencies. And this overhead is going to impact your system responsiveness, it's going to impact its scalability, and especially in the performance critical applications, it might not be worth it. And finally, the way it hinders software evolution is that it orders your dependencies. So the order in which decorators are applied, it can affect the behavior of your object, which can lead to subtle bugs or unintended outcomes, which can be very difficult to manage. It can be very difficult to debug and understand it. So managing and ordering these dependencies can be very challenging, especially if your system is evolving over time. So thank you for listening. Those were the 3 different patterns we looked at. We discussed how they can help facilitate and how they can hinder the evolution of software evolution. So I hope you took something away from this. Thank you for your attention.